Hey mathematicians, here are your notes 3.1, writing equations. So let's start off with the bell work at the top here. What is the key component of an equation and what makes it different from an expression? Well, the one thing that I always remember is that equation starts with EQ while expression starts with EX. Now, why does that matter? What does that tell us? Well, I always remember that equation sounds a lot like equals or equal to. And that reminds me that equal has a sign, whereas EX or EXP doesn't really have a sign. So the key component of an equation is an equal sign, and that's what makes it different from an expression. Another piece that goes along with this is an equal sign usually comes with a solution or an answer. If I'm given an expression like 2x plus 3, I'm not looking to solve this problem so much as learn what it's telling me. With an equal sign or an equation, I'm looking for a solution. So what are some words or phrases that might let us know that we're working with an equation? Well, an easy one is solution. What is the solution to this problem? Another word for solution might be answer. Can you answer this problem based on the information given? The final one is a verb, solve. Can you solve this problem? All of these are indicators that we're writing an equation, not an expression. Today's goal is to be able to write equations in equivalent forms to solve problems. Notice, because I'm using that verb again, I want to solve problems. I'm working with an equation, not an expression. So let's consider this real life example right off the bat. The population of the United States in 2001 was about 284 million, and the land area of the United States is about 3,500,000 square miles. It says find the average number of people per 1 square mile in the United States. Well, much like miles per hour or kilometers per minute, I'm going to write what I'm looking for. I'm looking for the number of people per 1 square mile. That's my unknown. That's what I'm looking for right now. And I'm given these two pieces of information that I have 284 million and 3,500,000. If I know that I want my final answer to look like number of people over square miles or per, based on that division sign, I should probably set up my original information the same way. So if I have 284 million people, that's the number of people. I could write that out. I'm just going to leave it in words. 284 million per 3,500,000 square miles. But I want this bottom number to be 1, not that 3,500,000. So to go from 3,500,000 to 1, I have to divide the denominator to get to 1. I have to do the same thing with the numerator. I'm going to divide that. Another way of looking at it is just saying if you've got 284 million on top, 3,500,000 on bottom, we can just divide that and find the same answer. No matter if you look at it as a ratio or if you just look at it as one problem, we're still trying to find the solution or the answer. So once we actually calculate that out, put it in our calculator, we're going to find that it is approximately, not exactly, but approximately 81 people per 1 square mile. Now, why is this problem interesting? Why is it important? Well, we could kind of reason our way through this. However, as we go further in math, it's going to get harder and harder to do that, to just see the answer off the top of our head based on the information given. So if we want to be able to work in any scenario, we need to be able to translate each problem, or in this case, each sentence, into an equation. So let's do that. If I give you the sentence 2 times the sum of x and 3 minus 4 equals 4 times x, I need you to be able to put that into math language instead of words. So let's go through this one and see what it looks like. I broke it up, as you can see in this table, by pieces to make it a little easier on us. So 2 times the sum of x and 3. 2 The symbol for times is often a dot. I'm not going to use an X because, as I was talking about in yesterday's video, we often use X to be a variable. If we're using X as a variable but also as times, that can get a little confusing. So I'm going to use the dot in this case. The sum of X and 3. The sum means we're adding the two terms X and 3. Notice because this has its own box and it says the sum of, that's indicating that we need to keep this together regardless of what's going on the left or right side of it. So I'm going to put some parentheses on that to remind myself. Minus, that's an easy one, 4 equals, gives us that equal sign again, 4 times X. 4 times X. Now this is a great organizer to see how we break it up, but this isn't what we're going to write on our paper when we're doing bigger math problems. We have to put this all back together. So that's what I'm going to do. 2 times the sum of X and 3. I'm not going to put that times in. I'm actually going to start taking that out a little bit. So instead of writing 2 dot X plus 3, I'm just going to say 2 times X plus 3, and I'm going to put them right next to each other. It just cuts down a little bit on the notation I have to use. Minus 4 equals 4 times X. And again, I could write 4 times X, but to cut back, I'm just going to do 4X. So notice, if we read this through, we should read the same sentence that we started off with. 2 times the sum of X plus 3. Notice we put those parentheses in there so that you read it that way. Minus 4 equals 4 times X. We got that one. You can pause the video here and try the next one on your own, or if you're not quite ready, we'll do the next one together. So the difference of K and 3. We've talked a little bit about the word difference. That means the exact opposite of sum. So when it says the difference of K and 3, that means subtraction. Again, difference is an indicator that we need to throw some parentheses on, the same way that we did with our sum. Is, that's another tricky one. Is means the same thing as equals. So the difference of K and 3 is, sometimes you can put equals behind it, is equal, is 2 times K divided by 5. So the difference of K and 3, again, I'm going to keep putting that parentheses. Anytime I see that phrasing where two things are together with an and in the middle, that's really going to indicate that we need parentheses to keep everything organized. K minus 3 is 2 times K divided by 5. Now I can either write the division symbol, or I can make this into a division problem. K minus 3 is equal to 2K divided by 5. Either of those would be correct. All right, let's flip it over. Important, the phrases the difference of, the sum of, the product of, or the quotient of indicate parentheses are needed. Remember, if you see and with two things on either side of it, that usually means parentheses. All right, let's keep working through some more of these. Translate the following sentences into an equation or formula. 10 times the number x is equal to 2.8 times the difference of y minus z. We can put this into boxes, or we can just kind of slowly work our way through it. In this case, I'm just going to slowly work my way through it. 10 times a number x. 10 times a number x. And you may need to do this in more than one step, and that's okay. Is equal to 2.8 times the difference, that's one of our key phrases up here, difference of y minus z. Y minus z. Now, this is great. I could leave it like that. It would technically be fine, but I'm going to clean it up a little bit and get rid of those multiplication symbols just to simplify how it looks a little bit. And there you go. I usually box my answers. In this case, because it's kind of a long one, I'm going to leave it. You can clearly tell that that's my answer, so it's okay. A number m minus 8 is the same as a number n divided by 2. Okay, a number m minus 8 is the same as. Is the same as means is equal to. So I'm going to put an equal sign. Is the same as a number n divided by 2. Just like that. This one looks pretty clean. Anytime I see that division symbol, I personally go to fractions. I prefer the way that fractions look. So I'm going to clean this up and just say m minus 8 is equal to n divided by 2. I personally like how that looks a little bit better. If you don't, that's okay too. The area of a rectangle equals the length times the width. This one might catch you up a little bit. You might be a little confused because there's no numbers. Here's the thing. The area of a rectangle, that is one big idea that we have to work with. Equals is an easy one because we know it's an equal sign. And then it gives us two more big ideas, length and width, separated by times, which we know is another math symbol. Even though there's no numbers or specific variables here, we can still create this problem by giving them our own variables. So the area of a rectangle, well, A stands for area, so let's use that one. Let's use L for length and W for width. If we remember back to whenever it is that we learned our area of rectangle formula, this formula is correct because A does equal L times W, just like that. I know that's a little confusing to see. I promise there's a little multiplication sign in there. Number 4, 22, even though it's in letters, I'm going to write it out in numbers, times the difference of A and B. The difference of indicates I need some parentheses. A, the difference is addition, subtraction, multiplication, or division. It's one of those 4. In this case, it's subtraction. The difference of A and B is, that's my equals, 54, just like that. Clean it up a little bit. 22A minus B equals 54. And there you have it. Number 5, the area of a trapezoid is the product of 1/2 the sum of the two bases and the height. Careful, this one is tricky. Again, there's no variables, so let's just start finding those big ideas. Well, the area of a trapezoid, there's no number or letter attached to it, but I know area is usually A. The product of is the product of. Product of usually means times. And then it says of 1/2 the sum of the two bases. That's a lot. I know 1/2, I know sum, and two bases. And remember, because it says the product of, that's going to indicate that we're going to need some parentheses. So let's start pulling this down. The area of a trapezoid is the product of 1/2. The sum of. The sum of indicates I need those parentheses. And it says of the two bases. Well, how do I indicate the two bases if I don't have any variables? In this case, I'm just going to give those bases some variables myself. Base 1, base 2. You could use B, C, whatever you like, as long as you indicate that they're separate. The sum of the first base and the second base. It says the product of 1/2 the sum of the bases and the height. So we're still working with a product here, which means I then have to multiply by h. Let's read this again. The area of a trapezoid, A, is the product of 1/2 the sum. There's the sum of the two bases and the product of the height. And we got that one. That one's really tricky. But again, if you're confused, start giving some variables to those concepts so that you can work with them a little bit easier. All right, last thing. We have to be able to also go in the other direction. So can you translate in the other direction? Let's do that with the following equations and put them into verbal sentences. And these have a lot of different answers. So long as they're mathematically correct and I could put them back into the original form, I will take your answer. So in this case, I would say maybe 4 times a number A, minus 5 is 23. You could also say 4 times the number A minus 5 is equal to 23. And there's a lot of variations. This one here, I'm going to go with 10 plus K is equal to 4 times a number K. Again, so many different options. As long as I can translate it back correctly, you're good to go. And one last helpful hint, problem solving usually involves exploring the problem, so reading through it, seeing what information you're giving, kind of planning, that's, taking into account what variables are given, solving, in that case, or in our case, that's writing things out, and then examining to make sure that what you did actually makes sense. That's going to come in handy for our next video. Let me know if you have any questions.